Hey everyone, welcome back to Civil Aviation 254. Let's dive into something super cool today. We are talking about aerodynamics. Yes, the science of flight. Have you ever wondered how airplanes soar through the sky or how a kite dances in the wind? It's all thanks to aerodynamics. In simplest terms, aerodynamics is the study of how air moves around objects. Think about it. Air might seem invisible and intangible, but it's made up of tiny particles called molecules. When these molecules collide with an object, they create forces. Aerodynamics is all about understanding and manipulating these forces. It's like an invisible dance between air and objects. By understanding the steps of this dance, engineers and scientists can design airplanes that fly, cars that slice through air, and bridges that withstand powerful wind. Aerodynamics is a very fascinating field that affects many aspects of our lives. Let's dive in and explore the amazing world of air in motion. Now, let's meet the stars of the show. The four main forces of aerodynamics: lift, weight, thrust, and drag. These forces are constantly interacting, and their balance determines whether an object will fly, fall, or stay put in the air. First up, we have lift, the force that counteracts weight and keeps an aircraft aloft. Lift is generated by the shape and angle of the wing as they slice through the air. Next, we have weight, the force of gravity pulling everything towards the Earth's center. It's the force that needs to be overcome for an object to become airborne. Then, there is thrust, the force that propels an object forward. Think of the powerful engines of an airplane or the flapping wings of a bird. They generate the thrust needed to move through the air. Finally, we have drag, the force that resists an object's motion through the air. It's like an invisible hand trying to slow things down. Understanding these four forces is crucial to understanding how anything from a paper aircraft to a jumbo jet moves through the air. Now let's talk about a principle that's key to understanding lift, Bernoulli's principle, named after the Swiss mathematician Daniel Bernoulli. This principle states that as the speed of a fluid, like air, increases, its pressure decreases. But how does this relate to flight? Imagine air flowing over an airplane's wing. This wing, curved upper surface, forces the air to travel a longer distance than the air flowing under the flat bottom surface. This difference in distance means the air on top has to move faster. And according to Bernoulli, faster moving air creates an area of low pressure. Meanwhile, the slower moving air underneath creates an area of high pressure. This pressure difference generates lift, pushing the wing upward towards the area of low pressure. Bernoulli's principle is like magic, but it's really just clever physics. It explains how aircrafts defy gravity and soar through the sky. While Bernoulli's principle explains lift, we need Sir Isaac Newton's laws of motion to understand the bigger picture of flight. Newton's first law of motion, often called the law of inertia, states that an object at rest stays at rest and an object in motion stays in motion at the same speed and direction unless acted upon by an unbalanced force. This means that an airplane needs thrust to overcome its inertia and start moving, and it needs continuous force to keep it moving against drag. The second law explains how force, mass, and acceleration are related. It states that force acting on an object is equal to its mass times acceleration. This law helps us understand how much thrust is needed to accelerate an aircraft to a specific speed, and how the aircraft weight affects its ability to take off and maneuver. Finally, Newton's third law of motion, it states that for every action there is an equal and opposite reaction. This law is evident in the way airplanes generate thrust. As the engine pushes air backwards, the air pushes back on the engine with an equal force, propelling the airplane forward. It's like an invisible game of tug of war that keeps the airplane soaring through the sky. Aerodynamics in aircraft design. Aerodynamics plays a crucial role in design of aircraft, from the shape of the wings to the materials used in construction. Engineers spend countless hours in wind tunnels and use computer simulations to optimize designs for maximum lift, minimal drag, and optimum fuel efficiency. The shape of an airplane's wing is crucial for generating lift. The curved upper surface and the angled shape, known as airfoil, are carefully designed to create the pressure difference described by the LIF principle. The fuselage or body of the airplane is also designed with aerodynamics in mind. Its streamlined shape helps reduce drag and allow for smoother airflow. Even the smallest details, such as the placement of antennas and the design of landing gear, are considered to minimize drag and improve aerodynamics performance. By carefully considering every aspect of an aircraft's design, engineers can create machines that soar through the sky with efficiency and grace. Taming the wind. Aerodynamics in wind engineering. Aerodynamics isn't just for airplanes, it also plays a crucial role in designing buildings, bridges, and other structures that interact with wind. Wind can exert enormous forces on structures, especially at high speeds. By understanding aerodynamics, engineers can design buildings that withstand these forces and remain stable. For example, tall buildings are often designed with tapered shape, narrowing towards the top. These shapes help to reduce the wind load on the structures by allowing wind to flow smoothly around it. Bridges, too, are designed with aerodynamics in mind. The shape of the bridge deck and the design of its supporting towers are carefully considered to minimize wind resistance and prevent any lead to instability. Wind tunnels and computer models help engineers analyze how wind will interact with different designs, allowing them to optimize structures for safety, stability, and longevity. Aha! Here we go, efficiency in the air, saving fuel with aerodynamics. In a world increasingly focused on sustainability, aerodynamics is more important than ever. By reducing drag, engineers can make aircraft more fuel efficient, leading to lower emissions and reduced operating costs. One way to improve fuel efficiency is by optimizing the shape of the aircraft. For example, winglets. Those small upward-pointing extensions on the tips of wings help reduce drag by altering the airflow around the wing. Another approach is to use lighter materials in constructions. Composite materials, such as carbon fiber, are strong and lighter than traditional aluminum, allowing for significant weight reduction and improved fuel efficiency. Airlines are constantly looking for ways to improve fuel efficiency, and aerodynamics plays a key role in these efforts. By designing aircrafts that slip through the air with minimal resistance, we can reduce our impact on the environment and create more sustainable future for aviation. Safety first, aerodynamics and flight stability. Aerodynamics is not just about efficiency, it's also crucial for safety. An aircraft's stability and control in the air are directly related to its aerodynamic characteristics. The design of the wing, tail services, and control services such as ailerons, elevators, and radar all contribute to an aircraft's stability and maneuverability. For example, the tail fin and radar help to control yaw, which is the side-to-side movement of the aircraft's nose. The ailerons, located on the trailing edges of the wings, control roll, which is the rotation of the aircraft around its longitudinal axis. The elevators, located on the horizontal stabilizer, the small wing-like surface at the tail, control pitch, which is the up and down movement of the aircraft's nose. By carefully balancing these control surfaces, engineers ensure that aircrafts are stable, predictable, and safe to fly. Aerodynamics in everyday life. Beyond aircraft, aerodynamics is crucial in our life. We often associate aerodynamics with airplanes and aerospace. Its principles apply to many other aspects of our life. For example, car manufacturers use aerodynamics to design vehicles that are more fuel efficient and handle better at higher speeds. The streamlined shapes of modern cars are testament to the importance of reducing drag. Architects use aerodynamics to design buildings that are more resistant to wind load, especially in areas prone to high winds and hurricanes. Even athletes benefit from aerodynamics. Cyclists wear aerodynamic helmets and clothing to reduce drag and improve their performance. Swimmers work on their body position to minimize drag and dive through the water more efficiently. Aerodynamics is all around us, influencing the design of objects both big and small. The future of flight. The field of aerodynamics is constantly evolving, with engineers and scientists pushing the boundaries of what's possible. One area of active research is development of more efficient wing designs. This includes exploring new airfoil shapes, using advanced materials, and incorporating morphing technology that allows wings to change shape during flight to optimize performance under various conditions. Another exciting area is the hybrid and hybrid electric aircrafts. These aircrafts have the potential to significantly reduce aviation's environmental impact, and aerodynamics will play a key role in maximizing their efficiency and range. Further researchers are exploring new concepts like supersonic and hypersonic flights, which would allow us to travel at speeds faster than the speed of sound. These advancements require overcoming significant aerodynamic challenges, but the potential benefits for transportation and space explorations are enormous. Aerodynamics is crucial, shaping everything from the way we fly to the way we design our buildings and vehicles. By understanding the principles of aerodynamics, we create machines that are more efficient, safer, and sustainable. Whether it's designing the next generation of aircrafts, building skyscrapers that can withstand hurricane winds, or simply understanding how a kite flies, aerodynamics plays a crucial role in our lives. As we continue to push the boundaries of technology and innovation, our understanding of aerodynamics will become even more critical, shaping future of flight and beyond. Curious to learn about these forces? Join us in our next video as we explore these principles in detail. Don't forget to like, share, and subscribe to Civil Aviation 254 to stay updated. Let's keep the journey through the skies going.